Hey everybody, it's Mr. Mott. Let's go over our Honors Chem Semester 2 final exam review. All right, this will be page 1 with all the stoichiometry on it. First thing we want to be able to do is balance this equation. We're going to use it for a few other problems on this page. I would first probably start balancing out my carbons. I've got 4 carbons on the left and only have 1 on the right. So I'm going to put a 4 in front. Next, I could do oxygens or hydrogens. The hydrogens I'm going to do actually next because I've got an even number here and an even number here. My oxygens are not even. So I'll do my hydrogens next. So I'm going to put a 5 in front because now I have 5 times 2. I have 10 just like I have on the reactant side. All right. Next, I want to count up my oxygens. I only have 2 on the reactant side. On the product side, I have 4 times 2, I have 8. And then this 5 also distributes, so I have 5. So adding those up, I have 13. So I have an even number on the reactant side, the 2, and on the product side, I have an odd number. So what I'm going to do is I'm going to put a 6.5 here because 6.5 times 2 gives me 13. But because we don't really like to see fractions or decimals in our equation, I'm going to multiply everything by 2. So now my new coefficients are 2, 13, 8, and 10. And we're going to use this balanced equation for the rest of our page here. On the final exam, what you're going to see is not something that you have to balance all of them, but maybe you're missing one of these and you have to balance it. All right. Looking at number 1, getting down to our stoichiometry, we have 4.52 times 10 to the 30th molecules, and we want to convert that into moles. This means moles of O2. So molecules are the units that have to go on the bottom, so they cancel, and then moles are going to go on top. Conversion factor between molecules and moles is Avogadro's number. So for every 1 mole, there's 6.02 times 10 to the 23rd. All right. So then calculating that out, it works out to be about 7.51 times 10 to the 6th moles of oxygen. All right. Next problem here, I have 3.5 moles of O2 is my given. What we want to find out are moles of H2O. The only time these are compared to each other is in the balanced equation. So moles of O2 are on the bottom, moles of H2O on the top. We can do this in one step because our units of our equation are moles, meaning these coefficients represent moles. And so our equation tells us that for every 10 moles of water that are made, we needed 13 moles of oxygen. And again, that's coming from our equation, 13 moles of oxygen for every 10 moles of water. All right. Doing our math here, 3.5 times 10 divided by 13 gives us around 2.7 moles of water. Okay. Problem 3 says if we have 50 grams of C4H10, we want to know how many moles of oxygen that we're going to need. So first thing that we need to do, be able to use our equation where these 2 chemicals are compared, convert from grams to moles of C4H10. Units of grams of C4H10 have to go on the bottom. So we want to recognize the units that we need, or the units of moles per gram tell us that we're dealing with molar mass. Molar mass of C4H10 is around 58 grams. At this point, we're in moles of C4H10. Now we can convert to moles of our new chemical, moles of O2. Moles of C4H10 need to go on the bottom so they cancel out. From our equation, again, our moles of O2 are 13. For C4H10, they are 2. Again, we're finding these from our balanced equation. All right. Multiplying the numerators, dividing by the denominators, we should get around 5.60 moles of O2. Problem number 4 says if we have 100 grams of O2, that's our given, we want to know grams of CO2. So first we're comparing different chemicals. We have to use the equation. Equation's in units of moles, so we're first going to convert our units of grams of O2 into moles of O2. Grams of O2 on the bottom, so our units cancel. The units of moles per gram tells us we're using the numbers our molar mass. Molar mass of O2 is 32. Moles of O2 need to go on the bottom to cancel, and we need to have moles of CO2 on the top. So once we've converted into moles of O2, then I can compare moles of O2 to moles of CO2. From our equation, the moles of CO2 are 8, and for O2, 13. Next, we convert from our moles of CO2 to grams of CO2. Moles of CO2 need to go on the bottom, so our units cancel. Grams per mole tells us we're using molar mass, and for CO2, that's around 44 grams. Multiplying the numerators and dividing by the numbers in the denominator, we get around 84.62 grams of CO2. Next problem says if we have 5 moles of C4H10 and 10 moles of O2, how many moles of CO2 will you make? Well, we want to recognize this is a limiting reactant problem. You can recognize it because you have 2 different amounts of your reactants. Chances are one of those is going to run out before the other and therefore be a limiting reactant. As we know, the limiting reactant limits the amount of product that can be made because it runs out first. So this asks us to find moles of CO2. So we're going to set up 2 equations. 5 moles of C4H10. We're going to convert that to moles of CO2. And then we'll do the same thing with our other reactant, 10 moles of O2. Convert that to moles of CO2. So moles of C4H10 are going to go on the bottom, moles of CO2 on the top. From our equation, the moles of CO2 were 8, and for moles of C4H10, it was 2. So this should work out to be about 20 moles of CO2. And then moles of O2 need to go on the bottom, and then moles of CO2 on top again. That's 8, and this is 13, again from our equation. This works out to be about 6 moles. And the smaller amount of product is made, so that's why we end up with 6 moles of CO2. Number 6 is an extension of number 5. It asks us how many moles of excess reactant will you have left over. So what we know is that since the smaller amount of carbon dioxide, smaller amount of product came from the oxygen. Oxygen is our limiting reactant, therefore the C4H10 is the excess reactant. So we need to figure that out, and there's multiple ways of doing this. What students tend to like to do is take our products that we calculated there and subtract them. This is step 1 of our process. There's always 2 steps in this. So we would have 14 moles of CO2. And then we're going to convert that to from moles of CO2, convert that to our excess reactant, which is C4H10. Moles of CO2 are going to go on the bottom. Moles of C4H10 go on top. This was 2 and this was 8. All right. So 14 times 2 is 28, divided by 8 gives us around 3.5. Again, there's multiple ways of finding this out, and we should end up with the same answer. All processes finding excess require 2 steps. All right, so that's page 1 of our review, and you can check out our other pages in our other videos. Thanks for watching.